Today we are going to be modeling Poiseuille, Couette, and hybrid flows in Fluent. So I'm going to start by creating a new Fluent workspace, and we're going to make a geometry for our flow to go through. Alright, now that we're in Design Modeler, we want to select our plane. We'll do XY plane since it's just going to be a flow. And we're going to want to make a rectangle. Oh, before that, we actually want to change our units to millimeters. And now we can make a rectangle. I don't want to change it too much. Expand it out. Like that. Okay. So we have been given directions. Make the length 50 times the height. So I'm going to dimension the length to be 250 millimeters and the height to be 5 millimeters. Vertical is 5. It's 250. Length. Yeah, alright. Now with that, all we have to do is create a surface from the sketch. And we're just going to be selecting all the lines to create the surface. Apply. And generate. And now we have our surface, and I believe that is all we need to do here. Now we can open up the meshing. Alright, so now with our shape, we're going to want to basically make our calculations as accurate as possible. So we're going to come to Method, we're going to select this geometry, selection, and now we have our geometry. And now we're going to want to essentially create lines of spacing in between. So now we're going to select sizing, select, oh, we want to get the edges, this edge, and edge. We're going to apply that. And we're going to want this thing by number. We're going to divide it 100 times. Work. Click generate. And now we want to do the same thing to the top, bottom edges. So that again. Here and go to number of divisions. Apply. I'll want to divide it by, let's go 250. And we will generate again. And now this looks alright, but one more thing we want to add, I believe, is the face mesh. We're just going to select this body, apply, and now we should generate. And now we have all our divisions. And there's one last step we can do. We have to label our entry points. So we're going to go back to edge select. We're going to pick each one of these. We'll hit N to name it. This will be the inlet. So weird. Whatever. Inlet. We'll select this one. It'll be, hit N again. It'll be the outlet. We'll select the top, hit N. It'll be top wall. Bottom. It'll be bottom wall. And now we've done all our meshing that we need. And we can come back here and update the meshing. Alright, now that the meshing's all set up, we start setting up to simulate our results. We'll do it in double precision. I hope that's it. So now that it's all set up, we have to get a couple things set up. The first thing we want to do is go to physics and then viscous. And since we want all our flows to be laminar, so we're just going to select laminar. And now we actually have to change the Reynolds number for that to make sure our flow is laminar. So we're going to come in here and edit the air. Now density is going to be 1 just to make it easy. And then to keep this thing at a Reynolds number of 1,000, we'll go 0.0005. That should be close. And now we'll set up our boundary conditions. Got the inlet with, we'll want it to have an inlet velocity n. Outlet should just be a pressure outlet. And we're going to leave the walls alone. They'll just be stationary right now because we're working with the Poiseuille flow first. Other than that, I think we're all set to initialize. Go ahead, initialize the calculation. And then we can run them. Oh, wait, no. We want to go through this 500 times. That'll be enough, guys. And now we're going to watch it convert. So I'm going to leave this window open because we're going to come back to it. But now we're going to go get our results. Alright, so in here, we'll just want to create a velocity contour real quick. I don't need to name it. It will be on velocity in x direction. Location will be symmetry 1. And we'll have 200 contours. Alright, so we're starting to see the the Poiseuille flow, where it's 0 at the top and bottom, and then in the middle it kind of, see the boundary layer developing. And now we'll go graph it. Actually, no, first we should make 2 lines, because we have to plot the velocity profiles at the midpoint and at the end. So I'm going to insert, where is it? I forget. Oh, no. Location, line. Okay. So line 1 will be at the midpoint. Since this is in meters, we're going to have to convert everything to meters. So our x direction will be 0.125 on both of them. And our y will be 0 here and 0.005, I believe. Yeah. So that'll be line 1. And then we'll do that again for line 2. Except this time it'll be at the end. So 0.25, 0.25, and, oh, no. 0. This one, I'll just use the slider. Perfect. Okay, now that we have our 2 lines, we can insert a chart. And on this chart, we'll name it velocity profile in type. And we'll plot our 2 series. This will be midpoint, and its location will be 1. And we will add end. Its location will be line 2. X-axis display velocity. Y-axis display y. Yeah, I believe that's good. And we should see, yep, we should see the laminar velocity profiles here. And now that we have this set up, all we have to do is go change our flow conditions, and we can see the same results for Couette and hybrid. So let's go back. For Couette, what we want to do here is we'll want to change the inlet, have a velocity of 0.5, and we'll want to change the top wall. So we'll double the velocity of, so it'll be a moving wall, go 1 meter per second. Okay, and we will change the viscosity of air because we just want this thing, we want to bring down the Reynolds number so it stays laminar. And we initialize. And if all goes well, should have a Couette flow, but we will see. One thing I did forget to do really quickly is want to change the outlet to just be outflow. Don't want any pressure in your calculation. So we'll initialize here, and now we will calculate. Alright, that took a little while, but the calculation should finally be complete, and we're going to go into Fluent. Just going to automatically update our data and hopefully see the Couette flow. Oh, it looks like a pretty linear distribution. Let's go over and check the chart. Yep, it's perfectly linear. So this is with the top moving plate and the bottom plate is stationary, and you can see how consistent it is with the theory learned. And now we'll just make a couple of simple changes to get the hybrid flow. So we're going to come back. We want this to be pressure outlet. We want this to be pressure inlet. And we will keep our moving, I'll keep our moving plate since it's the hybrid one. And now we will initialize and run our calculation for the final time. It finally finished, so maybe we'll have good results. Gotta figure out what's wrong with it. Maybe remove. No, let's add an extra 0. That fixes it. Oh, that converged rather quickly. I think we should be looking at what we wanted now. And it looks like we might have it with how it looks. Let's check the table. Yeah, that looks good because we have our laminar velocity profile, and at the bottom it's 0, and at the top it will be the speed of the plate, which is 1. So this looks good. I think we've got it. So our Reynolds number was a little bit too big that first time we simmed it, but now it's good. So there is our flow simulation in. Thank you for watching.